So topic for today's lesson is probability density function and cumulative distribution function. Okay, so we have two goals. First, we'll talk about the basic idea, intuitive idea of probability, and then probability density function, what it means. And then we will verify certain properties of probability density function. And then we will be solving some of the applied problems, okay, involving probability density function. So these are the goals for today's lesson. First of all, recall from your middle school or high school that the basic formula for probability. So the probability is probability of something to happen. Let's say probability of the occurrence of event, certain event. It is number of favorable outcomes divided by number of possible outcome, right? We know this basic formula. Number of favorable outcomes divided by number of possible outcome. For example, suppose you are given a deck of playing card, okay? So how many total cards are there in a playing card? I believe everybody know that the total cards is 52. Suppose if I want to draw what is the probability of drawing a let's say heart, a heart card. What is the probability? How many cards are there? How many heart cards are there? Altogether, there are 13. So number of favorable outcomes is 13. And the number of total possible outcome is 52. So the answer is going to be 1/4. So you already know that, right? So that's the idea. Now, if I ask you, what is the probability of drawing a king? So how many kings are there in a full deck of cards? There are 4 kings, right? In a full deck of cards, there are 4 kings. So 4 out of 52. So that's going to give you 1/13. So you already know this idea in your maybe elementary school, middle school, or high school. Now, so let's talk about probability function. And you also know that function means, a function means, suppose let's say y equals x squared. Let's say we can consider this as a function, right? Or maybe y equals to 2x, for example. This is a function, right? F of x equals 2x. It is function because when x equals 1, your y, or f of x, y equals 2. When x equals 2, your y equals 4. When x equals 3, and your y equals 9, and so on. So for each x value, there is a y value. And if you draw the graph, for example, y equal to 2x, so this is the graph of y equals to 2x. Now, this one is is a function clearly, because in your high school you learn that it is a function if it passes the vertical line test. So if you draw a vertical line, it just cross at one point. Okay, that kind of graph is the function. Okay, so for each x there is one y, there is only one y. Now if I ask you, let's say x equals y square, for example, in this case if you draw the graph, then your graph is going to be this one. This is your x equals y square graph. Okay, now this is not a function, because when you when you do the vertical line test, as you can see, the graph crosses at 2 points. So for each x there are two y values, therefore this is not a function. So this is a function and this is not a function, because for each x value it cannot have two y values. Whereas if you look at this y equals to x squared, for example, is this a function? Let's check. Y equal to x squared is a parabola. This one is your y equal to x squared. And if I draw a vertical line, notice that each of the vertical line cross the graph at only one point. That means for each x there is one y. Yes, this is a function. Okay, it is a function. So you already know that. So the reason that I'm talking about this function and probability is that now we will be talking about probability function. It's not only a function, but it is a probability function, guys. Okay, at this time you already know the basic idea of probability. You already know basic idea of function. And in this section, all the functions that we deal with are it's a continuous random variables. Maybe we'll talk about that in a minute. Now let us look at one simple example. Okay, suppose that a bank is studying the transaction times of its teller. The length of time spent on observed transaction rounded to the nearest minutes is given below. What it means is there are 3 transactions which were completed within approximately 1 minute in the bank. Okay, there are 5 transactions which took approximately 2 minutes each. So there are 9 transactions and each of them took approximately 3 minutes, and so on. So we have the data, and the total number of people, total number of transactions is 75. Now if I want to calculate the probability, so if I want to calculate the probability of this, so the probability of the transaction that took only 1 minute, so you will say 3 out of 75, right? So 3 is the number of favorable outcomes and total possible outcome is 75. So 3 over 75, if you divide it, you're going to get 0.04. In the same way, if you want to find the probability of the transaction that took 2 minutes, what is the probability of, selecting a transaction that took 2 minutes? So that means there are 5 transactions that took 2 minutes. So 5 out of 75. So you're going to get 0.07 and so on. Okay, we have all of these. Now the total, if you add all of them, you're going to get 1. Therefore, the total probability, if you add them all, it is 1. Now one thing, we can consider this as a function because for each x value, there is only one y value, right? So we can consider these are as x or t for that matter, and this one as y or f of t for that matter, okay? F of t. So we can think this as a probability function. Okay, does that make sense to everyone? So we will consider them as a probability function because they are probability. We just calculated, and we can consider them as a function because for each x value, there is a y value. Now, a couple of observations here. Notice that each of these probability are non-negative. There is nothing negative here. They are non-negative. Let us say that it is f of t is the probability function. Then the one of the property that we just observed here is that f of t are non-negative. Okay, that's one observation. And the total probability is 1. And in integral calculus, in this course, we have been saying that the total, the sum, and we have this total from a to b. In this case, 1 to 10, but to be more general, let us suppose that the interval is a to b, and the total sum of all of them, we denote them by f of x dx equals 1. Okay, the total is 1. So these are the two things that we observe from this table. And these are exactly the same property that you need to remember, that the function, any probability density function will have. In another word, a function is called the probability density function if it satisfies these two conditions. Okay, let me repeat this. Here is the definition. So probability density function. The function f is a probability density function of a random variable x in the interval ab if it satisfies the following two conditions. F of x is greater than or equal to 0, which means it is non-negative, and then the total is 1. Now, let me ask you one question. In your high school, you know that the probability is always lies between 0 and 1, right? So the probability cannot be negative. It cannot be more than 1. And what surprises me is that sometimes when I give questions related to the probability and in the exam, and people sometimes get the answer, okay, probability is, let's say, 1.2. And some people get probability is, let's say, minus 0.5. They get this kind of answer, and they just think that their answer is right. But as soon as you see that the probability is more than 1, something is wrong there, okay? Your calculation may be wrong. You double check it. As soon as you get the negative value as the answer for the probability, that is also impossible. Something is wrong, okay? Just go back and check. Don't just leave your answer like that. Probability always lies between 0 and 1. Now, probability of something is 0, what does that mean? Can you tell me what it means? Can you give me an example? So the probability equal to 0 means it's the event is impossible. Event or outcome, whatever you call it, event E is impossible to occur, okay? Impossible. So this tells us impossible. One simple example is in this class, okay, Math 105, in this class, if I choose a student randomly from this class who just came from the moon today, is there anyone who came from the moon? No one, right? So it's impossible. There is no one just came to take the class from the moon. So that is one example. Okay, now P of E equal to 1. What does that mean? It means event E is certain to happen. Okay. For example, if I choose a student from this group, excluding me, who is taking Math 105 course, that is 100% sure, right? All the students in this class are taking Math 105. So that is one example that has probability equals 1. Now, when the probability is 1, then we say that it is 100% certain. I think you have heard that people sometimes say that, oh, I am 200% certain. That statement mathematically is not correct. Okay, you cannot say, because probability cannot be more than 100%. But what they are trying to say is that they are, trying to emphasize the fact that this is surely going to happen. Okay, even though the mathematical meaning, the literal meaning is, mathematically it is not wrong. Sorry, it is wrong to say that I'm 200% sure, but its figurative meaning is that the person is pretty sure. All right, too much talking. Let's come back to the main question here. Guys, I want you to memorize these two conditions. And also one thing, that in this course, at the beginning of the term, we started that integration, let's say f of x dx. It tells us just the antiderivative, right? We started our course with that idea. Integral is antiderivative. And later we talk about the definite integral. And then what it tells us is that it tells us the, let's say f of x is here, and a is here, b is here. When I say a to b f of x dx, I'm talking about this area. We defined that the definite integral represents the area under the curve, okay, within that interval. So we talk about this. And then we discuss about the double integral. And in the case of double integral, it gives us the volume. Now, in this section, we define the definite integral as probability. Okay, if x is continuous, a random variable whose distribution is described by the function f on AB, then suppose I have a function f of x, and if I calculate this, it gives me the area. So basically the area can be defined as a probability. Keep in mind, this is a different face of the same integral. We have already seen a different face of the integral, and here we look at the integration, definite integral, as probability. Okay. So in this section, when I say a to b f of x dx, it means it is the probability of the function from a to b within that interval a to b. Now, example 1. Decide whether the function defined as follows are probability density functions. So PDF, probability density function. Now, in example 1, we need to decide whether the given functions are actually probability density function or not in the given interval. Notice that a function is PDF or probability density function if it satisfies these two conditions. Okay, that's the definition. Now, let's look at part A. F of x is PDF. I write in short, okay, probability density function if it satisfies two conditions. Condition 1, f of x is positive. That's we need to check. And the second condition is a to b f of x dx equals 1. So we need to check this too. So first, to test or to check the first condition, to check first condition, you see clearly f of x is non-negative on the interval f of, let me just write down the function, clearly non-negative on the interval 2 and 5, right? So if you substitute any value for x between 2 and 5, this function is not going to be negative. It will not be negative, no matter what value you choose for x. If you substitute x equals to 2, still positive. If you substitute x equals to 2.5, still positive. 2.9, 3.2, 3.7, whatever value you choose, it's going to be positive. Okay, so it satisfies that condition. And you can simply write clearly. It doesn't require any rigorous mathematical proof. Okay, you don't need rocket science to say this. Just say obviously. Okay, now to check second condition, so first condition checks, right? So the second condition is a to b f of x dx equals a is 2 to 5. The function is 1 over 9x minus 1 over 18 dx, which gives me 1 over 9 x squared over 2 minus 1 over, just find the antiderivative here, 1 over 18x, and that's going to give me 2 to 5, which is 1 over 18. I can take that common, so the remaining is x squared, means 5 squared minus 5 okay, 5 square minus 5 minus 2 square minus 2. And I need your help, guys. If you just work it out, what do you get? 25 minus 5 is 20. And 20 minus, this is 4 minus 2 is 2. 20 minus 2 is 18. So you're going to get 1 over 18 times 18, which is actually 1. And it checks. The second condition also checks. Okay. So since f of x satisfies both conditions, it is a PDF. It is a probability density function. Any question? Okay. Just in case, if you notice that the first condition actually failed, then you don't have to do the second condition. Okay. So, and then these conditions are not in that order. You can choose. All you need to do is you need to verify that the given functions satisfy both of the conditions, regardless of the order. Okay. I want you to try part B just for fun. So part B is given function is 5 over 3 x squared minus 5 over 90 from -1 to 1. So test, okay, check two conditions. Check two conditions. Condition 1. My question to you is that is f of x is always non-negative on the interval -1 and 1? Is that true always? Check that. And okay, guys, here is f of x greater than or equal to 0 on the interval. Just use your common sense and suppose because one of the example is when x equal to 0, then your f of x is, then f of x becomes 5 over 3 0 square minus 5 over 90, which is negative, you see. So it failed. This first condition not satisfied. So you don't have to try the second condition. So f of x is not a PDF. Okay, guys? Now, let's look at another example too. Find a value of k that will make f a probability density function on the indicated interval. All right. So we need to find the value of k here that will make the function a PDF. Okay, in another word, what will be the value of k so that the function will be PDF over this interval? Remember, we have two conditions. One condition is the function must be non-negative. Another is integration from a to b must be 1. This is an inequality. Even if we solve this, if we consider that first condition and solve it, then these kind of inequality gives us, does not, may not give us a particular value. So for simplicity, you may want to start with this because this is an equation and you will get a one or two, doesn't, depending on the function, you will get a definite value from this one, okay? So for f of x to be a PDF, it has to satisfy two conditions. So condition one is a to b f of x dx equals 1. So that means a is 0 to 3, your function is kx dx equals 1, which means if you evaluate the integral, you're going to get kx squared over 2 and 0 to 3 equals 1. So that's going to give me k over 2, which is 9 square minus 0 square equals 1. So that's going to, not 9 square, 3 square. And so if you simplify it, so you're going to get 9k over 2 equal to 1. So this is going to give me k equals 2 over 9. Okay. So if k equals 2 over 9, then this will satisfy this condition. Now we need to check the second conditions, okay? Let's see, I'm going from here to there, okay? So if k equals 2 over 9, then the function, then f of x becomes, you see the function is kx, which means k kx, which means 2 over 9x, right? That's our function. Now we check the second condition. We check the second condition, which is f of x is greater than or equal to 0. We'll check that. Clearly, f of x is greater than f of x equals, you see, k is, our function is 2 over 9x, is always non-negative on the interval 0 and 3, right? No matter what value you choose for x between 0 and 3, you will never gonna get negative here. Okay, it's just a common sense. So it satisfies this condition as well. Therefore, k equals 2/9 makes the function f of x a PDF. Any question? Okay, so remember, start with the equation, start with the integral a to b f of x dx equals 1, and this will give you the value of k, and make sure that that value of k will actually satisfy the other condition of the PDF, which is the function is non-negative within that interval. So these are the two steps you need to do. I want you to try part B on your own just for fun. Okay, try part B just for fun, which is f of x equals kx cubed, and then interval is given 2 to 4. And let me know what is the value of k. Okay, anyway, so I trust that you are able to do this on your own, and basically, you start with the condition, one of the condition, which is a to b f of x dx equals to 1, which means 2 to 4. You can write the language, okay, so you need to write why you can do this, but I leave it to you because we have done similar question just a few minutes ago. And so this one equals 1, so you'll get 2 to 4 kx cubed dx equals 1. And so yeah, continue this, and the value of k will be 1/60, because so many of you got the same answer, and I trust that this is the correct answer. Okay, and once you get this answer, you verify that the function, here in the function with this k value will satisfy the other condition, which is the function is non-negative. So I leave it to you. Now the next concept that we'll be talking about is cumulative distribution function. Now it may be beneficial to you to recall from your high school statistics what is the meaning of cumulative, okay? Cumulative distribution function. If f is a probability density function of a random variable in the interval AB, then the cumulative distribution function is defined as f of x, the probability p, capital X less than or equal to small x, equals a to x f of t dt for all x greater than or equal to a. Okay, so what it means is, let me just remind you your high school basic idea of cumulative distribution function. Cumulative distribution, what does that mean? Suppose, let me give you one random example. Let us suppose that this one is just a mark in math exam, okay? And this one is number of student. Number of student, and we denote that by frequency, and this one is cumulative frequency, which means CF. Guys, I'm taking it to high school just for a few minutes, okay? I hope that you don't mind, because you need to understand what is the cumulative frequency actually means. Let us suppose that this represents the marks in math class, okay? Okay, so the full mark in that exam is 25. Suppose there is one student who is scored between 0 and 5. Suppose there are 4 students who is scored between 5 and 10. Suppose there are 15 students who is scored between, let's say 10 students who is scored between 10 and 15. Let's say there are 5 students who is scored between 15 and 20. And let's say there are 10 students who score between 20 and 25. Okay. Now, cumulative distribution means how many students score from 0 to 5 is just 1. You write 1 there. And now in cumulative distribution, you cumulate this one and this one together. How many students score between 0 and 10? So that means you add 1 plus 4, which gives you 5. Now, cumulative distribution for this place is all the students who score between 0 and 15. So that means you add 1 plus 4 plus 10, which is 15. Okay, so that's how we find the cumulative frequency. So cumulative frequency actually varies depending on how many you consider. Okay, and this one, cumulative frequency is 1 plus 4 plus 10. But in this case, you know what we can do is we can simply write, we already calculated this 1 plus 4. Now you write 5 plus 10, which is 15. Now you'll have 15 plus 5, which is 20. Now you have 20 and 10. So you add them too. So 20 plus 10, which is 30. So the total number of students in the class is 30. Now cumulative distribution X. Sorry, in this case, now let's look at this. The lower limit is fixed. So the lower limit is fixed, okay, in cumulative distribution. But the upper limit is depending on how many items you want to consider. If you want to consider only these 2 items, your upper limit will be 10. If you consider these 3 items, then your upper limit will be 15. If you consider this 4, upper limit is 20. So that therefore the upper limit actually varies in cumulative distribution, okay? So the formula here, you see that the lower limit is fixed, constant, and upper limit is X, which varies depending on, you know, how big data, how big the items, how many items you want to consider. Okay, now we have the formula. Let's look at example 3. Find the cumulative distribution function for the probability density function f of x, which is 3 over 98 x squared on the interval 3 to 5. Okay, let us calculate that. So we know the formula is cumulative distribution function, CDF, is given by a2x f of t dt, or f of x dx for that matter. Okay, f of x dx or f of t dt, doesn't matter. Now your a is 3 and x is simply x, and your function is, let me write this, f of t equals 3 over 98 t squared, okay? So f of t is 3 over 98 t squared dt. All right, I wanted to give you the f of t here, but it was typed as x. Can you change it into t? Okay, that's it. Now you can find out what is it. So that's going to give me 3 over 98. So t cube over 3 and 3 to x, which gives me 3 over 98. Oh, this 3 and 3 cancel out. I can write 1 over 98. And so this will be x cubed minus 3. cube. That's it. So your cumulative distribution function is going to be 1 over 98 x cubed minus 27. That's it. Any question? Now, probability density function on the interval negative infinity to infinity. If f is a probability density function for a continuous random variable x on the interval negative infinity to infinity, then there are three situations. Okay, one is px less than or equal to b, which means the lower limit is negative infinity and upper limit is b. Okay, x is less than b. Less than or equal to, it's the same thing, doesn't matter. Okay, they are equal, because basically what it means is it just is a matter of 1 point. And when we look at the area, just 1 point doesn't make a difference. So px greater than or equal to a can be written as this way, a to infinity f of x dx, and the probability between negative infinity and positive infinity is given by this, and which is actually 1. Okay, keep that in mind. Now example 4. Consider the function f of x. It is a piecewise function. There are two pieces. One piece x cubed over 12 for x between 0 and 2. Another is this x greater than 2. Part A, so that the function defined as follows is a probability density function as above, not follows. Okay, defined as above, is a probability density function on the given interval. Okay, we want to show that this one is a PDF. I think I can leave it to you, but anyway, let's look at it quickly. Part A, to show that f of x is a PDF, check two conditions. Okay, check two conditions. Let us check that. First, clearly f of x is non-negative. Remember here, no matter what value you plug in between f of, let me just write down this. No matter what value you plug in between 0 and 2 in this function x cubed over 12, you will never get a negative value. And also any value greater than 2 for 16 over 3x cubed, you will never get negative. So this is clearly f of x is non-negative. Okay, it's pretty clear, it's obvious. You don't need any rocket science to know that. It's just a common sense thing. Okay, because f of x is greater than or equal to 0, there are two pieces. X cubed over 12 is always non-negative on the interval 0 and 2, and f of x equals 16 over 3x cubed is always non-negative on the interval 2 and infinity. Okay, because greater than 2 means 2 and infinity. Therefore, first condition is satisfied. Now, second condition, a to b f of x dx equals 1. That's what we need to prove. Let us take that. Notice that there are two pieces. So this will be piece number 1 from 0 to 2. That is the okay, for the first piece 0 to 2, the function is x cubed divided by 12. plus the second piece is 2 to infinity, which is 16 over 3x cubed dx. The sum of these two integrals should be 1. And let us check that. So I want you to try, okay, try this. 0 to 2, 1 over 12 x cubed dx. How much is that? That's going to give me 12. And x cubed will be x raised to power 4 divided by 4. And that's going to give me 1 over 48. So this will be 2 power 4 minus 0 power 4. So which gives me, how much is that? 2 power 4 is 16. It's 1 over 3. Okay, so we got 1 over 3 for the first one. Okay, this equals to 1 over 3. And in the same way, let us calculate the second one. The second one is, 16 over 3, 2 to infinity, x raised to power negative 3 dx. That is our second integral. Remember, it's an improper integral, so we always take the limit b tends to infinity, 2 to b x negative cube dx, right? That's how we solved it before, and we're going to use the same technique. And this gives me 16 over 3, and it will be x raised to power negative 3 plus 1, which is negative 2 over negative 2. It goes from b to 2 to b. So we'll get negative 8 over 3. And so you're going to get b negative 2 minus 2 negative 2. And I need to write the limit here. So the limit is limit b tends to infinity. Now, I trust that you know how to solve it easily. This will be 1 over b minus 1 over 4. And so this will be negative 8 over 3. And when you substitute the value of b, 1 over b means 1 over infinity, which is 0, minus 1 over 4. You're going to get negative, negative, positive, 2 over 3. Okay, so this part we got 2 over 3. Okay, so that means when you add them, you're going to get 1. Yes, so second condition also checks. Therefore, hence f of x is a PDF. Part A is done. Now part B. In part B, we need to find the probability. So find probability from 0 to 2. Okay, we need to find the probability of this. And remember, we define the probability as definite integral, right? So P0 to 2, x0 to 2 can be written as 0 to 2 f of x dx, which means 0 to 2, our function for that interval 0 to 2 is basically x cubed over 12 dx, okay? Right? So look at that. The function for the interval 0 to 2 is this function right here. For 0 to 2 is this, x cubed over 12. That's the piece. And you know how to evaluate the integral. The good thing is we already calculated this here. You see? We already calculated this here. So I just copy and paste. So your answer is going to be 1 over 3. Done. Any question? Now part C. Find probability of x greater than or equal to 2. So that means we know that probability is given by the definite integral. which is 2 to infinitive, okay, greater than 2. If you want, you can write this way too, if you want. So Px greater than 2 can be written as Px is greater than 2 and less than infinitive. You can write this way too, which means 2 to infinitive f of x dx, which means limit, well, I can simply write this 2 to infinitive. So for this interval 2 to infinitive, your f of x is 16 over 3x cubed dx. And the good news is we already calculated this integral here. All you need to do is copy and paste, okay, this integral right here, which gives me 2 over 3, done. Any question? Now I want you to try part D on your own. So the question in part D is, P probability between 1 and 3. I want you to calculate this on your own, okay? So what it means is, remember, there are two pieces. So one piece is, going back to the question, we are looking for the area under the curve between 1 and 3. So between 1 and 3. So from 1 to 2, we consider the upper piece, and 2 to 3, we consider the lower piece. So we'll split that into 2. Okay, one is one to 2 plus probability 2 to 3. Okay, we'll split that this way, which gives me 1 to 2 f of x dx plus 2 to 3 f of x dx. Now 1 to 2 f of x. So which piece is between 1 and 2? You already know that the first piece, which is, how much is that first piece? X cubed over 12 dx, plus the second piece is anything above 2, anything greater than 2, which is 16 over 3x cubed dx. And now this is a piece of cake for you. I trust that everybody will be evaluate this integral. I leave it to you and let me know what is your answer later, okay? Take a few minutes and try to complete it right now. So if you evaluate the integral, I trust that everybody will be evaluated. I leave it to you. And so the first part will be the second part will be and so all together, that's what I got. Can you? Okay, so you check this. This is what I got. And I want you to verify that. Make sure that I didn't punch the wrong button in my calculator. And if you get a different answer than this, let me know. Now let's move forward. Example 5. The life in months of a certain electronic computer part has a probability density function defined by and the interval is given 0 to infinity. Find the probability that a randomly selected component will last the following length of time. Okay, part A, at most 12 months. So part A, we need to find the probability that the electronic computer parts, the computer parts will last at least 12 months. What it means is we need to find the probability at least 12 months. That means 12 months. Oh, not at least, sorry, at most. At most 12 months means 12 or less. So that means you can start with 0 to 12. That's all we need to find. Okay, so this means we know that the probability is given by the definite integral, which is 0 to 12, and f of t dt, which is 0 to 12, and your f of t is e raised to power -2 negative t over 2 dt. And so if you evaluate this integral, you're going to get a half, and that will be e negative t over 2 over negative 1 over 2, and so this is going to be 0 to 12. So, and then it will be this half cancel out. Okay, this half and half cancel out, so you will get basically negative there. So you have e negative 12 over 2, which is 6, minus e 0, and that's going to give me negative 1 over e to the 6 minus 1. And I need your help, guys. How much is that going to be? Okay, so this one will be how much? Is it 0.99? This is what my calculator is giving me approximately, and I want you to verify this is the correct answer. Okay, so or this probability, or we can say almost 99.75%, 99.75% you can say. The chances that the computer parts will work up to 12 months is almost 100% sure, right? 99.75% certain that the part will actually last or actually work at least 12 months, at least 1 year. And that's why, like if you buy something, they will give you 1 year warranty, because they know that for 1 year, the chances of something to fail is really low. And if you want more than 1 year, then you have to pay the insurance, right? That's what happens because the manufacturer do not guarantee their product more than 1 year, just because otherwise they will, they will end up paying a lot of money for that warranty. Anyway, let's go to part B. Between 12 and 20 months. So we need to find probability of the computer parts will work between 12 and 20 months. 12 and 20 months. So what it means is you just find the integral between 12 and 20 f of t dt, which is half 12 to 20 e raised to power negative t over 2 dt, and then I leave it to you guys. Take a few minutes and let me know what is the answer. Okay, complete it just for fun. To do. So yeah, some of you got the answer to be approximately 0.0024, and all right, so that's the probability, which is pretty low. Okay, all right, and now part C. Find the cumulative distribution function for this random variable. Okay, so find cumulative distribution function. So we know the formula, right? Cumulative distribution function is given by a to x f of t dt. That's the formula. Recall from the previous slide, okay? Previous page. That's the formula we discussed earlier. So now we will substitute the value. The lower limit in this case is 0, right? So here, as you can see, the interval is 0 to infinity. So the lower limit is 0. Upper limit will be the variable x. Okay, this one is x. And the function is e raised to power negative t over 2 dt. Okay. So that means if you evaluate the integral, you're going to get e raised to power. Did I forget something here? Oh, half. Okay, thank you. Thank you. So here we'll have half of this. So let me just evaluate the integral. You're going to get half. And integration of this is going to be e raised to power negative t over 2 over negative 1 over 2. And then this is going to be 0 to x equals this half and half again cancel out. This half cancel out. So your term will be negative is there, and now if you plug in the value, you're going to get e negative x over 2 minus e raised to power 0. So which gives me negative e raised to power x over 2, and negative will be positive 1. So this is your cumulative distribution function. Let me just copy nicely. So what we got here is, therefore, cumulative distribution function CDF is given by a function f of x, which is e raised to power negative x over 2 plus 1. Okay, so this is your CDF. Part C is done. Let's look at part D, what we are supposed to do. In part D, use the answer to part C to find the probability that a randomly selected component will last at most 6 months. You know what? Let's try, instead of 6, let's try with 12 months. What happens? Okay, let us work with 12 months. I just want to change this 6 month into 12 month. So that means when x equals 12, so your f of 12 is going to be negative e raised to power negative 12 over 2 plus 1. I want you to calculate this, how much that's going to be. Negative e raised to power negative 6 plus 1. And what do you get? Which is also, you see, it's the exact same expression that we got in part A. So in part A, we got this expression, negative. So that's going to be 0.9975, right? Notice that this one and this one will be the same, is the same. They are actually equal. And what we did is, in part A, we simply use the basic idea that the integral gives us the probability. And in part D, we use the cumulative distribution function to calculate the probability. So you can use either one of the methods. And just in case, if you know, just for fun, you can try what is the probability when x equals 6, for example. You can calculate that as well yourself. Okay, any questions so far? Okay guys, so we did a lot of things related to probability, and we have seen that the probability actually can be calculated by using the integration. And right now I want you to try example 6 just for fun. Okay, try this example right now. Take a few minutes and let me know what is your answer. Okay, did you notice something here? I was checking how many of you are paying attention. Look at the domain. It starts from 3 to 6, so it cannot be 0, by the way. You need to pay attention to the domain. Okay, this is 3, so this one is also 3, so this is 3. We need to check the domain here. So 3, this one is 3, so that you'll have negative 12, 1 over 4, t squared means 16 minus 1 over 9. And how much that going to be? If you calculate this, I think it will be 7 over 12, which is approximately 0.58, or you can write 58 percentile approximately. Okay, so in the same way, in part B, you can write P, what is part B? Find the probability that a bulb will last at least 4 years and at most 5 years. So that means at least 4 years and at most 5 years, which gives me 4 to 5 f of t dt. And then I want you to try this on your own. And I just want to let you know that your final answer should be, okay, so the final answer should be approximately 0.27. Try this yourself. Okay, guys, I trust you that you'll be able to handle this. Okay, so this section is done.